Hello everyone, welcome to another video from Btech. So this video is exclusively for the upcoming examination of differential equations. So that is, we will discuss one repeatedly asked question from the module number 5, that is wave equations. Okay, I found this question asked 2 to 3 times and it carries about 10 marks. Here is the question number 22. A uniform elastic string of length 60 cm is subjected to a constant tension of 2 kg. If the ends are fixed and the initial displacement is this and the initial velocity is 0, find the displacement function u of x comma t. It carries about 10 marks. So let's see how it's done. Okay, here I have copied the question. Now I will explain it. A uniform elastic string of length 60 cm is subjected to a constant tension of 2 kg weight. Unit of tension is kilogram weight. And if the ends are fixed, the initial displacement of the string is given. Also the initial velocity is also given. That is, if we have a string whose end points are connected. End A and B are connected firmly to some point, okay, and the length of the string is 60 cm. So for such a stretched string, if I give some disturbance, what happens? The string starts to vibrate, isn't it? Or it exhibits some wave-like motion, isn't it? It starts to vibrate, and it is very clear from the figure that along the length of the string, that is at the beginning stage, at the starting point of the string, there is no up and down motion for the string. While I move on, when I reaches at this point, that if it is 20 cm, what happens? There is a vertical displacement, somewhat length is there coming up, and at the middle of the string, what happens? It has the maximum displacement, isn't it? So we can say that as the length proceeds, there is a variation in the displacement, and here the displacement variable is u. So we can say that u, or the displacement depends upon the length of the string. That is, let us take the length as x, length of the string. So the displacement depends upon the length of the string. As we just said, that is at the end points there is no displacement. The displacement is just 0, and it moves on. At the middle we can expect the maximum displacement, isn't it? And it is very obvious that as time progresses, the displacement will minimize, or the displacement will diminish. Why? Because damping occurs, isn't it? So we can even say that the displacement does depend on the time. So the coordinates or the parameters which make the displacement is x and t. So this is actually u of x comma 0 is actually u of x comma t, and for initial cases it is written here initial displacement. Initial means when time t is equal to 0, the displacement is this much, and it's also given as the initial velocity. Here the velocity at time t equal to 0, the velocity is 0. Anyway, let's put everything together. So now let's start answering. So you have to start with writing the partial differential equation of the wave motion. Partial differential equation for wave motion. It is dou square u by dou t square is equal to c square into dou square u by dou x square. U is defined to you, t is time, and x is also the length of the string is defined for you. And what about c square? C square is actually t by rho, or tension by rho. Here it is 2 divided by rho. Okay. Let it be. Rho is actually the mass per length of the string. If it is not given, let us write it as rho itself. Okay. Now next thing is solution equation for solution equation for wave motion. Actually, this equation is very important, from which we proceed to answer. U is actually A cos Px plus B sin Px whole into C cos Pct plus D sin Pct. Okay, so this is your displacement function, and it is very clear that U depends on x and t. As I have said, U depends on x and t, the length of the string and time, isn't it? So the displacement equation is also in terms of x and t. Now we have to get many equations from this particular question, and we have to substitute individually like conditions, and finally we will end up in the required function or the required displacement function. Okay, so let's start deriving the equations from the question. So let's start forming the equation. It is said that if the ends are fixed, the initial displacement is this thing. That means if the ends are fixed, then there is no displacement occurring at the endpoints, or there is no u at the endpoints. And endpoints here, here it is actually the length of the string, and here it is x equal to 0, and at the last end it is x equal to 0.6 meter, because it is given the complete length of the string is 60 centimeter. So at the point when x equal to 0 and when x equal to 0.6, there is no displacement, as it is tightly tied to one point, isn't it? So let's have u of x comma t. We usually express it as u of x comma t, isn't it? So u of x equal to 0, 0 comma t, at any point, at any time, the displacement at the end point x equal to 0, there is no displacement, isn't it? And at the final end, I mean x equal to 0.6, here also u of 0.6 comma t, at any point of time you are having the displacement at the point B. This is A and this is B. The displacement is just 0. Okay. So this is actually called as the boundary conditions. Why? Because here x that we took is the boundary, the endpoints of the string. Okay. And next time it is directly given initial displacement u of x comma 0. As I have said, initial means the term initial indicates t is equal to 0. So it is given directly that u of x comma 0 initial time. It is, there we have got a function 60x minus x square. Okay, and initial velocity. What is this velocity? Velocity is derivative of the displacement, isn't it? Dou y by dou t. This is the expression for velocity, and it is specified that initial velocity, so dou y by dou t at t equal to 0. Why I take partial derivatives means the function, the displacement function depends on two variables. If a function depends on more than one variable, we go for partial differentiation, isn't it? So dou y by dou t at time t equal to 0 is, what's the initial velocity? It is 0. Okay. So this is actually called, these are the two conditions when time is equal to 0. So we call it as initial conditions. Okay. So we have got 4 conditions. 2 are boundary conditions and other 2 are initial conditions. Okay. Now let's take the main expression of displacement function of a wave motion, and we will put individually these 4 conditions, and we will update or we will modify this answer equation, and finally we end up in the required solution. Okay, let's see it. So I have arranged the conditions and the solution equation side by side. Now let's substitute these conditions over to this equation, and let's see what's going to happen. Actually, our aim is to substitute the unknown values or to get the unknown values. Like here, A, B, C and D, also this P, small letter P, are the unknown conditions. C is actually known. Here the C is actually known because we did have like this C square is equal to 2 by rho. It is actually the parameter associated with the string. So C is something known. It's an arbitrary constant. But A, B, C, D and P are the constants which we need to find out. Okay, so let's substitute all these conditions one by one. First condition is this one. We have to get all these values. Okay, let us make it side. And so this is the first condition, and this would be the second one. And third, I will take this one. Why? Because we need the RHS term to be 0. Then only we will arrive at some values, and later after putting all this condition, that means whichever conditions is having RHS as 0, after all of them we will take the last thing. Here we have the RHS as 60x minus x square. This is known, so let us keep it for last. Anyway, condition 1. What's the condition 1? U of 0 comma t is equal to 0. That means put x equal to 0 and u is also equal to 0. Remember, the first coordinate is x, the second coordinate is t. So 0 comma t indicates x equal to 0, at that point u equal to 0. So let's put it in the equation. Just put u equal to 0 and a cos p into 0 plus b sin p into 0, and here c cos pct plus d sin pct. Okay, we know that cos 0 is 1 and sin 0 is 0. Cos 0 is 1 and sin 0 is 0. So let's substitute a into cos 0 1. So a plus 0 into c cos pct plus d sin pct equal to 0. So which term is going to be 0? Definitely this complete bracket is not going to be 0. Why? Because this is a part of our original equation. Then how can this be 0? If this was 0, then there is no point in the existence of u, isn't it? So this complete bracket cannot be 0. Then the only option is a equal to 0. So one variable is ready, that a is equal to 0. Okay. And next, let us put the condition number 2. Okay, before that, what we need to do is we have to upgrade this equation. That is, just put this a value over to this equation. Okay, so we have arrived at a new equation by putting this a value. That is, just need to put a equal to 0. So this term a cos px becomes 0. Then the answer is b sin px into c cos pct plus d sin pct. So now on, we are moving with this latest equation. Okay, so let me rub this one, and so this is our equation. Now on. Okay, now let's put the second condition. And what about that? Second condition is u of 0.6 comma t, that is x value is 0.6, it is 0.6, and at that point when x equal to 0.6, u is again 0. Okay, so let's put the same values over to this latest updated equation. So 0 is equal to b sin p into 0.6 and again c cos pct plus d sin pct. Okay, again which value is going to be 0? We have said that this is never going to be 0. And what about this? That means 0 is equal to b sin p of 0.6. Actually this completely it's an angle for sine. Anyway, again out of this which is going to be 0? B or sin p 0.6. B can never be 0. Why? Because if b is 0, then complete equation is going to be 0 only. So again our general solution will be a non-existing one. So let's not take b as 0. So b is not equal to 0, or let us specify that too. B is not equal to 0, and then the only possibility is to make sin 0.6p as 0, and we know that sin n pi is 0. So let's compare, that is n pi and 0.6p will be equal. So 0.6p is equal to n pi. Now we do want to get the value for p. Okay, p, I think you cannot see this p. Okay, p here value is, let's see, p is equal to n pi by 0.6. So it is actually n pi divided by 0.6. So p is also ready. Again, let's upgrade the equation. Okay, that is, let's substitute this p value over to here. There are three places, here, here and here. So let's substitute this n pi by 0.6. So I have substituted this p value again. Now for condition 3 and 4, we have to take this as the primary basic equation. Anyway, let's substitute condition number 3. What is that? We have to take the derivative. For that part, we have to substitute we have to get the derivative and then substitute t equal to 0 for that derivative. So let's write condition number 3 is dou y by dou t. We have to get dou y by dou t first, and for that equation, let's substitute t equal to 0 and dou y by dou t equal to 0. So let's take, actually this is not y, okay, sorry, it is actually u, because, okay, so let's take the derivative for u. Dou u by dou t equal to, this part becomes a constant because we are taking the derivative with respect to t. And now c cos n pi c by 0.6t. Derivative of cos is minus sine. So minus c sine n pi ct divided by 0.6. Have to multiply the t coefficient, that is n pi c by 0.6, plus derivative of d sine n pi ct by 0.6. Derivative of sine is cos. So d cos n pi ct by 0.6. Again multiply the t coefficient n pi c by 0.6. So here comes the derivative of u. Okay. And now we need to substitute t equal to 0 and dou u by dou t equal to 0. That means the LHS becomes 0 and t is also 0. When t becomes 0, what happens? Here it is sine 0. So this term completely goes to 0 because sine 0 is 0. And what about here? Cos n pi c into 0. So cos 0, this completely is going to turn as 1. Okay. So let's substitute again, b sine n pi x by 0.6 into d n pi c by 0.6 into 1. Okay. So our equation has now been reduced to, equation is now 0 is equal to bd. Let us write all the constants together, bd n pi c divided by 0.6 sine n pi x divided by 0.6. Okay. Now, again we have to check which variable is going to be 0. Definitely b is never going to be 0. And here also sine, it is already fixed. So only option is that let's take d equal to 0. Okay. So again it is derived for d value is 0. Again let's modify the green color equation by substituting d equal to 0. So what happens? Just we have to remove this, this term to 0. So our equation now gets reduced to bc sin n pi x by 0.6 into cos n pi ct by 0.6. Let me write the constants together. bc sin n pi x by 0.6 cos n pi ct by 0.6. Okay. Let me rub completely, because here onwards I need to say something. That is, u is actually now depending on n, isn't it? Here n, sine, for sine also there is n and cos also there is n. So let's write it as u is equal to bn sine n pi x by 0.6 and cos n pi ct by 0.6. So I have clubbed these two constants bc as bn because both the sine and cos depends on n value. That is why I took bc as bn, and also n takes up the values from 1 to infinity. So I put a sigma over here. Okay. Now it's time to put the condition number 4. What is this condition 4? It says that put t equal to 0, and at that point your u value is going to be 60x minus x square. Okay. So both these substitution must be done to the latest equation. Latest updated equation is u is equal to this thing, isn't it? So let's put 60x minus x square in the LHS equal to sigma n equal to 1 to infinity. Now put t equal to 0. So t value is just over here only. So cos 0, it turns to be 1. Cos 0 is 1, isn't it? So it is simply bn sine n pi x divided by 0.6 into 1. Okay. Now aren't you familiar with this equation? Yes, this is a Fourier series representation, isn't it? Fourier series says that f of x is equal to, actually it is Fourier half range sine series. F of x equal to sigma n equal to 1 to infinity bn sine n pi x by L. Okay, this is half range Fourier sine series. Half range Fourier sine series. And by comparison, it is very clear that f of x equal to 60x minus x square, and sine is ready, n pi x, and L is 0.6, and your capital Bn is small letter bn, and we do know the formula for Bn. What is that? Bn is equal to 2 by L integral 0 to L f of x sine n pi x by L dx. This is the basic Fourier, Bn coefficient equation, Bn coefficient formula. You can check the last video. And so let's find out capital Bn, because small letter bn is equal to capital Bn, isn't it? So once we substitute this L value and f of x value, and when we go do the integration, we get the value for capital Bn. Okay. So let's substitute it. 2 divided by our L value, by comparison, by mere comparison, it is clear that L equal to 0.6. So 2 divided by 0.6 integral 0 to 0.6. What is f of x? F of x is the LHS part, 60x minus x square and sine n pi x divided by 0.6 dx. Okay. Remember, our main aim was to get the values for the constant, isn't it? So here we have clubbed up all the conclusions, that is a equal to 0, b not equal to 0, and c is yet to be found out, and d is obviously 0, p is also ready. But c, actually b is not equal to 0, that's all, but yet we need to get the value for b, isn't it? So what we do is we just combine this up, b and c together, and get the value for bn. Okay, so let's continue doing the integration part. I go for table method approach. Just differentiate this half and integrate this half. Differentiate till 0 is got. So it is 60 minus 2x minus 2 and 0. Integrated. I have explained this method in my last video. You can just go through. So 60x minus x square into this part. Just continue multiplying and arrange it up. Okay, to 2 divided by 0.6 is 1 divided by 0.3. Okay, now 1 by 0.3 is just 10 by 3. Just substitute the limits. See, actually when there is sign coming up, we can actually avoid it up. Why? Because when I substitute this 0.6 over here, it becomes sine n pi 0.6 by 0.6, which means sine n pi is 0. So this term goes to be 0 when I substitute this 0.6, and I'll be left with this part. But I think we have to write the 60 as 0.6 because in the question it is described in centimeter, isn't it? So let us have it as 0.6x. Okay. So while substituting the upper limit, this term 0.6 into 0.6, it is 0.6 square minus 0.6 square, it becomes 0. And here also when I substitute 0.6 over here, sin n pi is 0. And finally we will be left with this part, that is when I substitute x equal to 0.6, 0.6 cut off and it is cos n pi. So minus 2 cos n pi divided by n pi by 0.6 the whole cube. Next time when we substitute this lower limit, it is 0. So 0 minus 0, everything is going to be 0, and here also sin 0 is 0, and here finally it is 2 cos 0, cos 0 is 1. So we will be left with negative 2 divided by n pi divided by 0.6 the whole cube. Which means we can take this n pi by 0.6 the whole cube outside. It's like 10 by 3 into n pi the whole cube, and 0.6 cube becomes in the numerator side, and negative 2, I think negative 2 is common to both the terms, so let's take it outside, negative 2, so it becomes negative 20, and cos n pi minus negative 2 is taken outside, so minus 1. So it is like negative 20 into 0.6 the whole cube divided by 3 n pi the whole cube minus 1 raised to n minus 1. Cos n pi value is negative 1 raised to n. Okay. Let me cut it short. It is negative 36 by 25 n pi the whole cube into negative 1 raised to n minus 1. And by seeing it, it is very clear that when n is equal to even number, minus 1 raised to even is 1. So 1 minus 1 is 0. So your Bn value will be 0 when n is equal to even. When n is equal to odd number, what happens? Minus 1 raised to odd number is negative 1. Again negative 1 minus 1 is negative 2. Along with this negative it becomes positive 2. So Bn value is positive 2 into 36 divided by 25 n pi the whole cube, which is about 72 by 25 n pi the whole cube. Okay. So Bn value is finally got. Okay. So I hope all the constant terms, unknown terms are found out. So Bn value is also found out now. Now let's replace or let's update the previous equation which was derived from the condition number 3. So this is the latest equation. So let's replace it with let's modify it with Bn value. What is that? Just clear this Bn and write this value. 72 by 25 n pi the whole cube, and remember we have the n value, we have n as only odd terms, isn't it? So it is like n equal to odd, or you can even write n is equal to 1, 3, just specifying it as odd number. Okay. So this is our final displacement function. So that's all with the 10 marks wave equation question. Actually it's very easy but quite lengthy. I'll tell you as in a flowchart. That is, you know the general expression for or general wave equation solution, and you apply the condition number 1 and you will get the constants, like you get the values for constant, like constant equal to something. And by substituting this constant values in the main equation, you will get a new updated equation, isn't it? A new equation will be got. Again you move on to condition number 2, again you get the constant, and again this value, this constant value is substituted in the latest equation, and again you will be generated with another new equation. So it goes on like this, and finally you will end up in the desired answer. So do well in your exams. Hope you like the video. Till we meet in the next class, this is Meenu signing off. Thank you and take care.